Section 6.3, Elimination. Essential question. How do you determine what to eliminate in a system of equations? All right, so we are now to our third method of solving a system of equations. You've learned how to graph, you've learned how to do substitution, and now this lesson is going to introduce you to elimination. Remember, all three can solve a system of equations. It just depends on which method you want to use. All right, so we'll use elimination to solve the system of equations. So we have a system of equations off to the left here. Oops. And you'll notice one thing about this one is that rather than there being a variable all by itself on one side like there was in substitution, elimination has opposites. So x and y are on the same side, and one of the variables is making opposites, meaning we're going to be able to eliminate something. So if you look at this system, and you look at what you can eliminate, meaning what makes 0, 6 and negative 6 make 0. So right away we're going to cross those off. That can be eliminated. Then all we're going to do is take what's left and add it. So 4x and 3x make 7x. Because they're both positive, so you add them together, bring down our equal sign. 32 and 3 make 35, so all we're doing is adding. Then if I solve this by dividing both sides by 7, I get x equals 5. Now, I have to take that 5 and plug it into one of my equations to solve for y. I can pick whichever equation I want to. Normally, I like to pick the top one. I kind of do the top one just as an easy, always go-to equation to plug it into. So I'm going to put 4, and then I'm going to replace x with 5 plus 6y equals 32. And then I'm going to go ahead and solve that equation. So 4 times 5 is 20. And then if I minus 20 on both sides, I end up with 6y equals 12. Divide both sides by 6, and I get y equals 2. So now I'm going to take my x of 5 and my y being 2 and write it as an ordered pair. So if I graph these two equations, they would intersect at the ordered pair 5, 2. All right, second one, same thing. So x and y are on the same side in both equations, and we are going to look for our opposites. So what makes 0? This time, it's our 4 and negative 4. So I'm going to x those out because they're gone, they made 0. Then I'm adding 3 and negative 5 this time. So you have to look at the sign right in front of the number. Last time they were both positive. This time we have a positive and a negative. So 3 and negative 5 make negative 2. And then if I add negative 3 and positive 5, I also get 2. So divide both sides by negative 2, and I'm left with y equals negative 1. Then I'm going to take that negative 1 and plug it in either equation. Like I mentioned on the last problem, I like to plug it into the top one. So negative 4x plus 3, and then I'm replacing y with negative 1 equals negative 3. 3 times negative 1 is negative 3. Add 3 to both sides. So negative 4x equals 0. Divide both sides by negative 4. And I have x equals 0. Write my final answer as an ordered pair. So 0, comma, negative 1. All right, third one. Okay. Third one, I'm going to look for my opposites. If it helps you, you can put 1s in here. Might help you to see the opposites a little bit better. So 1 and negative 1, the y's, make 0. 1x and 1x make 2x. 7 and 9 make 16. Divide both sides by 2, and I have x equals 8. Take that 8 and plug it in for x in my top equation. So 8 plus y equals 7, minus 8 on both sides. And I have y equals negative 1. So 8, negative 1 is my solution. All right, last one. Write and solve a system of equations. So this time we're given a word problem. So we have to first of all write a system of equations, and then we have to solve it. So the first thing we need to keep in mind is we need to write two equations, because a system of equations means two equations. They also have to both need two variables, and they have to be the same two variables. Usually we'll use x and y. So keep that in mind. Two equations, and each equation needs the same two variables. Okay. In a situation like this, our first sentence, the sum of two numbers is 47. That's going to make our first equation. So first of all, we have to think of what the word sum means. In math, the sum means addition. So the sum of two numbers. We don't know what the two numbers are, so that's going to be our two variables. So if I add my two variables together, is, meaning equals, so the sum of two numbers is 47. All right, so we have our first equation. Second equation, the difference is 13. So first of all, I know that difference means subtraction, and is 13, so equals 13. So now really all I'm doing is I'm subtracting these two numbers. So x minus y equals 13. Now I can solve this. So this one looks just like the last one where I have x's and y's but no coefficients. So if you want to, you can put the ones in front. Our y's are what's going to cancel. So 1x and 1x make 2x. 47 and 13 make 60. Divide both sides by 2. And I have x equals 30. And I'm going to take that 30 and plug it in to my top equation. So 30 plus y equals 47. Subtract 30 on both sides, and I get y equals 17. Now if I wanted to check that, the sum of two numbers is 47. If I add 30 and 17, I get 47. So I could check this. 30 plus 17 equals 47, which is what I wanted. 30 minus 17 equals 13, also correct. This one you don't have to write it as an ordered pair when you're done, because really they just want us to find the two numbers. So our two numbers are 30 and 17. Summary.